On Christmas morning in 2021, people around the world found themselves holding their breath as the most ambitious telescope ever created rose from French Guiana and headed out into the vast darkness of space. It was the result of 30 years of work, a $10 billion commitment, and countless sleepless nights shared by thousands of engineers and scientists across the globe, all converging on that single, fragile moment. At last, the James Webb Space Telescope had begun its journey, a mission destined to transform the way we understand the universe. I often wonder where you're listening from right now. Take a moment to share your time and location. There's something quietly humbling about reflecting on these cosmic discoveries while we're all scattered across this small blue planet, each of us beneath the same ancient sky that Webb is now revealing in ways we once thought were impossible. Let's begin, because what makes Webb's story truly remarkable goes far beyond its scale. This is not simply another space telescope with a larger mirror or more advanced instruments. It is humanity's first truly clear view into the cosmic dawn itself. A kind of time machine capable of looking back more than 13 billion years, allowing us to glimpse the universe as it was in its earliest moments, still glowing with the fading light of its creation. Welcome to a journey through one of the most extraordinary chapters in the history of space exploration. We'll follow how a telescope drifting in the cold darkness a million miles from Earth has already forced us to rewrite textbooks, question fundamental ideas, and confront cosmic phenomena we never even knew were there. The discoveries we're about to explore are not just impressive scientific milestones, they are revelations that reshape how we understand our place within the vast, unfolding story of the cosmos. The story opens with a detail that often catches people off guard. Webb doesn't circle Earth the way its famous predecessor, the Hubble Space Telescope, does. Instead, it travels far from home to a unique location known as Lagrange Point 2, a region of space where the combined gravity of Earth and the Sun creates a calm, balanced place to stay, about 1 million miles away. From this vantage point, protected by a sun shield the size of a tennis court, offering the equivalent of SPF 1 million, Webb drifts in constant darkness. Its instruments are cooled to temperatures even colder than Pluto, allowing it to sense the faintest signals from the distant universe. None of this exists just to show off clever engineering. Every single feature has a deep scientific reason behind it. The universe, after all, is expanding. As light journeys across billions of years, it stretches much like a rubber band being slowly pulled apart. Light that began its life as visible radiation from the very first stars and galaxies has been stretched so much that it now arrives as infrared radiation, invisible to our eyes, but perfectly suited to Webb's advanced detectors. So when Webb gazes deep into space, it is also looking back through time. The farther it looks, the closer it gets to the universe's earliest moments. It's like holding a cosmic archaeology tool, one capable of peeling back layer after layer of cosmic history, exposing secrets that were... And yet, even the most hopeful astronomers weren't ready for what Webb would actually uncover. Just months after starting full scientific operations in July 2022, this extraordinary observatory began transmitting images and measurements that left researchers astonished, thrilled, and genuinely puzzled. One of the earliest shocks came from the deepest reaches of space and time. In May 2024, Webb detected something that shouldn't be there, at least according to our best theories of how the universe evolves. It observed a galaxy known as JWST 140 shining brightly in the cosmic darkness only 290 million years after the Big Bang. To give that some scale, if the entire history of the universe were squeezed into a single calendar year, this galaxy would have appeared by January 8th. This finding is about far more than setting a new distance record. It strikes at the heart of our understanding of how quickly structure can emerge after the universe's fiery beginning. According to existing models, galaxies this large and luminous simply shouldn't have had enough time to form so early. Peter van Dokkum of Yale University, one of the scientists involved, summed it up when he explained that this is currently the most distant object known to humanity, and more importantly, that Webb was never expected to detect galaxies like this so early, especially at this point in the mission. The consequences of this discovery are profound. If galaxies could grow this massive so soon after the Big Bang, it implies that the early universe was far more energetic, far more efficient at building complexity than we ever assumed. It's like uncovering evidence that ancient societies weren't just capable of constructing great cities, but were doing so faster and with greater efficiency than modern civilizations equipped with advanced tools. And this galaxy wasn't a lonely exception. Webb has revealed a whole population of unexpectedly massive galaxies in the early universe, some rivaling the Milky Way in size, all forming within the first 700 million years of cosmic history. These immense systems challenge the foundations of our galaxy formation models and force us to rethink how quickly matter could gather under gravity's steady pull. The puzzle deepens further when we look at what these ancient galaxies are made of. Webb's spectroscopic instruments allow it to treat distant starlight like a laboratory sample, splitting it into precise wavelengths that expose which elements are present. What emerged from this analysis was startling. These early galaxies show unusually high levels of nitrogen compared to what we see in our own sun and nearby stars, while many other heavy elements appear in much smaller amounts than expected. This hints that stellar evolution, the process by which stars create heavy elements and spread them through supernova explosions, unfolded under conditions very different from those we observe today. It's as though we've stumbled upon evidence that ancient metalworkers were crafting complex alloys using methods we can't yet explain, producing results that our current understanding says shouldn't exist. These results point to something important. Our current ideas about how stars shape the chemical evolution of galaxies are still unfinished. In other words, we don't yet fully grasp the cosmic processes that eventually led to the formation of planets like Earth and, in the end, to our own existence. The story becomes even more intriguing when we look at the shapes of these ancient galaxies. Webb has shown us that many very distant galaxies are not shaped like the familiar spirals or smooth ellipticals we see nearby. Instead, they appear flattened, oval, disc-like, even tube-like in form. This was a real surprise and demands much more study before we can properly explain it. It's rather like uncovering evidence that ancient builders used completely different design principles from those we rely on today, creating structures that are elegant and functional, yet governed by rules we're only just beginning to decode. What these observations seem to tell us is that galaxies in the early universe followed developmental paths that our existing theories struggle to describe. But Webb's discoveries don't stop with galaxies that are unexpectedly active and full of life. It has also revealed galaxies that are remarkably quiet, almost lifeless. These are galactic remains, the leftovers of furious bursts of star formation that took place at the cosmic dawn. They burned intensely and briefly, used up their fuel, and then slipped into a long period of stellar inactivity. While telescopes like Hubble and observatories on Earth had spotted such dead galaxies before, only Webb has the sensitivity to analyze their light in enough detail to determine how long they've been dormant. It's like having a cosmic forensic laboratory, one that can tell us not only that something ended, but also when it happened and under what conditions, offering vital clues about the birth, life, and death of galaxies in the early universe. The scientists studying these early Webb observations have been very clear about how transformative they are. As one researcher put it, before James Webb, we simply didn't have direct observational evidence to help us understand the physics of the early universe. Now, for the first time, we're able to connect the theoretical idea of the Big Bang with the extraordinary variety of cosmic objects scattered across the night sky. These findings are pushing cosmologists to confront deep questions about dark matter, about how efficiently stars formed in the early universe, and about the true timeline of cosmic evolution. Some researchers are asking whether our existing models can be adjusted to fit these surprises, or whether we need to rethink from the ground up how the universe moved from a simple beginning to the richly structured cosmos we see today. The discussion is still very much open. Some scientists argue that star formation in the early universe must have been incredibly efficient, allowing massive galaxies to take shape far more quickly than they do now. Others believe the answer may lie in revising our understanding of dark matter itself, that unseen substance providing the gravitational framework around which galaxies assemble. What's beyond doubt is that Webb is delivering real observational data from a period of cosmic history that, until now, existed only in equations and computer simulations. For the first time, we're seeing direct evidence of what the young universe actually looked like, rather than relying on careful guesses drawn from what we observe in our nearby cosmic surroundings. The significance of this goes well beyond academic interest. These discoveries are reshaping our story of cosmic origins. The account of how the universe evolved from a hot, dense, relatively simple state into the complex and structured place we inhabit today. Exploring these early eras isn't just about curiosity or wonder. It's about understanding the basic rules that allow complexity to emerge from simplicity, structure to arise from apparent chaos, and the essential ingredients of stars, planets, and life itself to spread throughout the universe. As we find ourselves at the edge of these extraordinary insights, we may be witnessing the most profound shift in cosmology since Edwin Hubble revealed that the universe is expanding. Webb's view of the early cosmos suggests that cosmic evolution unfolded faster, more efficiently, and with greater intensity than we ever expected. And yet, these glimpses of the distant universe are only the beginning of Webb's impact. Its abilities reach far beyond ancient galaxies, extending to objects much closer to home, uncovering new details about how planets form, how stars live and die, and how the conditions for life might arise in environments that are at once familiar and completely alien. The account of Webb's discoveries is still unfolding, with every new observation adding another layer to our understanding of the universe. What we've explored so far represents only the opening pages of what is shaping up to be a vast and compelling story of cosmic exploration, one that will continue to grow as this extraordinary instrument looks farther into space and further back in time than any human-made device ever has. As Webb shifted its infrared vision away from the distant cosmic dawn and toward our own stellar neighborhood, it began uncovering details that had long been hidden in plain sight. One of the telescope's great strengths is its flexibility. It can investigate not only the oldest objects in the universe, but also planets circling nearby stars, worlds that might possess the right conditions for life to emerge and endure. Imagine this scene for a moment. Just 40 light-years from Earth, a small red dwarf star is orbited by 7 rocky planets, packed so closely together that if you were standing on one of them, the others would loom larger in the sky than the Moon does when seen from Earth. This is the TRAPPIST, one system, first identified in 2017 and quickly recognized as one of the most intriguing planetary systems ever discovered. What makes TRAPPIST one so fascinating is not only the presence of multiple Earth-sized planets, but also the possibility that some of them lie within that narrow, precious region around their star where liquid water could exist on the surface. Red dwarf stars like TRAPPIST-1 are the most common stars in the Milky Way. If Earth-sized planets around red dwarfs can hold on to their atmospheres and sustain liquid water, then the number of potentially habitable worlds in our galaxy could be immense. However, there has always been a concern. Red dwarfs, despite their long lives and overall stability, are turbulent in their youth. They often produce intense stellar flares and radiation capable of stripping atmospheres from nearby planets. For many years, astronomers debated whether the planets of TRAPPIST-1 were lifeless, airless rocks scorched by their star, or whether some of them might have managed to retain the vital layer of gas needed to support liquid water and, possibly, life. Webb has begun to shed light on this question with a level of precision never achieved before, and the findings are both revealing and unexpected. Using its mid-infrared instrument, Webb accomplished the first direct detection of thermal emission from a planet as small and relatively cool as the rocky worlds in our own solar system. This achievement marks a milestone that would have seemed nearly impossible only a few years ago. The researchers focused first on TRAPPIST-1b, the innermost planet in the system. By measuring the infrared heat emitted from its surface, they found that the planet's dayside temperature reaches around 500 Kelvin, or roughly 450 degrees Fahrenheit. Even more telling, the data indicate that TRAPPIST-1b does not possess a substantial atmosphere. It serves as a stark reminder of how unforgiving space can be when it comes to preserving the delicate balance required for life as we understand it. The fierce radiation from the red dwarf star appears to have stripped away any atmospheric gases that may once have surrounded this planet, leaving behind a bare, rocky surface exposed to relentless stellar energy. Webb's investigation did not end with that world. The telescope then turned its attention to TRAPPIST-1d, a planet located farther from the star where conditions might be more favorable for maintaining an atmosphere. This planet lies in a region where liquid water could, in theory, persist on the surface, making it an especially compelling candidate in the search for habitable environments beyond our solar system. After careful examination of Webb's spectroscopic data, the results showed that TRAPPIST-1d also lacks an Earth-like atmosphere. As Caroline Payale-Gorayeb from the University of Chicago explained, while the ultimate goal is to determine whether Earth-like environments can exist elsewhere and under what circumstances, Webb's observations allow scientists to rule out TRAPPIST-1d as a potential Earth twin or close cousin. And yet, as some possibilities fade, new ones emerge. A recent reanalysis of Webb's data on TRAPPIST-1b has opened up intriguing alternative interpretations. Different observational methods and wavelength ranges can highlight different characteristics of these distant worlds, and the latest analysis suggests that the innermost planet might, in fact, host a hazy atmosphere rich in carbon dioxide. Another possibility is equally compelling. The measurements could point to an unusually high surface temperature, hinting that the planet may be geologically active, perhaps dominated by intense volcanic processes that continually release gases into the atmosphere even as radiation from the star works to strip them away. This draws attention to one of the most extraordinary features of Webb's abilities. The telescope can examine these distant worlds using several different methods, with each approach uncovering a separate part of the overall picture. It's rather like working with a collection of microscopes, where each one is designed to reveal details that the others simply can't see. The meaning of these investigations goes far beyond the TRAPPIST, one system alone. By learning how planetary atmospheres endure, or are stripped away, around red dwarf stars, scientists are gaining essential insights into planetary habitability across the entire galaxy. These observations allow astronomers to improve their models, helping them determine which kinds of planets might be able to support life and under what specific conditions that support could exist. Yet Webb's study of alien worlds has not focused only on planets that might be habitable. The telescope has also turned its gaze toward the most extreme objects known, the supermassive black holes that sit at the centers of galaxies and sculpt the universe through their overwhelming gravitational pull. What Webb has revealed about these cosmic giants has been nothing short of transformative. In the constellation Telescopium, the telescope identified a small, compact red object that existed just 500 million years after the Big Bang. This faint red point contains what may be the earliest known black hole ever observed, a gravitational heavyweight that challenges nearly everything we believed about how such objects are born and how they grow. The black hole, at the core of Galaxy Kuiper's LRD XE9, has a mass of roughly 30 times that of our Sun, making it about 10 times more massive than Sagittarius A*, the supermassive black hole at the center of the Milky Way. What makes this discovery especially astonishing is that this ancient black hole accounts for around 5% of the total mass of all the stars in its host galaxy, a proportion far greater than anything seen in the present-day universe. Stephen Finkelstein, one of the astronomers involved, captured the importance of this result when he noted that it adds to the growing evidence that early black holes either grew far more rapidly than we thought possible or began their lives already far more massive than current models predict. The consequences of this finding are profound. In the modern universe, supermassive black holes usually contain only about 0.1% of the stellar mass of their host galaxies. Discovering a black hole with such an outsized share of mass so early in cosmic history suggests that these objects were not merely larger than expected, but were accumulating mass at rates that appear to challenge our understanding of how matter falls into gravitational wells. The puzzle deepened further when Webb detected the most distant black hole merger ever recorded. In May 2024, the telescope found evidence of two massive black holes in the process of merging within the galaxy system ZS7, an event taking place just 740 million years after the Big Bang. This is not only a new distance record, but also the earliest point in cosmic history at which such a phenomenon has ever been observed. Black hole mergers rank among the most energetic events in existence, releasing more energy through gravitational waves than all the stars in the observable universe emit as light. The fact that these mergers were already happening within the first billion years after the Big Bang implies that supermassive black holes reached their enormous sizes through extremely rapid growth and frequent collisions even when the universe was still very young. Perhaps the most intriguing possibility of all is that Webb may have uncovered evidence for direct collapse black holes, massive objects that form not by slowly feeding on the remnants of stars, but through the sudden collapse of enormous clouds of gas. As part of the Cosmos Webb survey, astronomers identified a strange object nicknamed the Infinity Galaxy, which shows two compact red nuclei surrounded by rings, forming a shape that resembles the mathematical infinity symbol. This unusual structure appears to have arisen from a head-on collision between two disk galaxies. But what makes it truly exceptional is the supermassive black hole located between the two nuclei, embedded within a vast reservoir of gas. The research team suggests that this black hole formed through the direct collapse of the gas cloud itself, a mechanism that could explain how some of the extraordinarily massive black holes discovered by Webb in the early universe managed to reach such immense sizes so quickly. These direct collapse scenarios act like a kind of cosmic shortcut, allowing black holes to bypass the slow growth from stellar mass beginnings and instead start their existence already millions of times more massive than our Sunday. It is much like finding evidence that certain mountains appeared suddenly rather than being shaped slowly by long, gradual geological processes, but instead through enormous fragments of rock arriving from space already fully formed. Yet, perhaps the most extreme finding of all came from Webb's observation of a black hole feeding at rates that should be impossible under our current understanding of physics. By combining data from Webb and the Chandra X-ray Observatory, astronomers identified a low-mass supermassive black hole, existing just 1.5 billion years after the Big Bang, that is consuming material at more than 40 times the theoretical limit. This process, known as super-Eddington accretion, takes place when a black hole absorbs matter faster than radiation pressure is supposed to permit. It's rather like discovering a drain that somehow empties a bathtub faster than water can possibly flow into it, directly challenging what we think we know about the laws governing such systems. Hyewon Soo from the International Gemini Observatory, who led the research team, explained that this result implies a substantial fraction of a black hole's mass can be gained during a single, intense episode of rapid feeding, regardless of whether the black hole began as a light or heavy seed. These short-lived but extreme feeding events could help explain how supermassive black holes reached such enormous sizes within the relatively brief window of the early universe. These black hole discoveries are not just about isolated, curious objects. They are uncovering deeper truths about how the universe organized itself during its earliest stages. The connection between supermassive black holes and the galaxies that host them appears to have been established very early in cosmic history, suggesting that these gravitational giants played a decisive role in shaping the structure and long-term evolution of the cosmos. As Webb continues to look farther into space and further back in time, each new finding adds another piece to the broader picture of cosmic evolution. The telescope is revealing that the early universe was not the calm, simple environment we once imagined, but a highly dynamic and rapidly changing place where massive structures emerged with unexpected speed and efficiency. These insights into black holes and distant galaxies represent only a small part of Webb's far-reaching influence on astronomy. Its remarkable flexibility allows it to investigate phenomena across a vast range of scales, from the smallest brown dwarf stars to the largest structures in the universe, with every observation deepening our understanding of how everything fits together. The narrative takes another fascinating turn when we move beyond the familiar limits of our own galaxy. For decades, astronomers have identified thousands of brown dwarfs, mysterious objects that occupy the boundary between planets and stars. They are too massive to be planets, yet they lack the sustained nuclear fusion that defines true stars. These unusual objects have been found scattered throughout the Milky Way, but always within our galactic neighborhood. Then, Webb accomplished something that once seemed nearly impossible. It detected the first substantial population of brown dwarf candidates beyond our galaxy, located within the star cluster NGC 602. Elena Manjavakis, from the Space Telescope Science Institute, captured the importance of this moment when she pointed out that until now we had known of about 3,000 brown dwarfs, and every one of them was found inside our own galaxy. This achievement goes beyond simply expanding a catalogue of known objects. By examining young, metal-poor brown dwarfs in an environment entirely different from our local region of the Milky Way, astronomers are gaining valuable insight into how stars and planets formed under the harsh conditions that dominated the early universe. It's uncovering artifacts from an ancient civilization on a previously unexplored continent, objects that reveal how life unfolded under circumstances completely unlike those of today. Webb didn't stop with the discovery of brown dwarfs in other galaxies. It went further, pushing the limits of what we believed possible in the process of star formation itself. The telescope identified a new record holder for the smallest free-floating brown dwarf ever observed, an object with only 3 to 4 times the mass of Jupiter, drifting through space without any parent star. Kevin Luhman from Pennsylvania State University, who led this study, explained that one of the most basic questions posed in astronomy textbooks is simply what the smallest stars are. Webb is now helping to address that fundamental question by revealing objects that challenge our assumptions about the minimum mass required for star-like formation. This tiny brown dwarf, together with 2 other ultra-low mass objects found in the same survey, marks the extreme lower boundary of what can form through processes similar to those that create stars. These objects are so small and so cool that they sit right on the boundary between failed stars and giant planets, blurring a distinction astronomers once thought was clear. As a result, scientists are being pushed to rethink the basic processes that control how matter collapses under gravity to produce different kinds of cosmic bodies. The picture becomes even more fascinating when we consider that Webb has also detected brown dwarfs encircled by protoplanetary disks, the rotating clouds of dust and gas from which planets emerge. In the Orion Nebula, the telescope confirmed 20 brown dwarfs hosting these planet-forming disks, showing that even these failed stars can hold on to the raw ingredients needed to build planetary systems. This finding runs directly against earlier theories, which suggested that brown dwarfs were simply too small and too cool to sustain the conditions required for planet formation. Instead, Webb is revealing that the pathways leading to planets may be far more common and far more varied than we ever suspected. It's a bit like realizing that small businesses not only survive in difficult economic climates, but can also generate entire networks of related enterprises around them. The consequences of this insight spread through our understanding of how widespread planetary systems might be across the galaxy. If planets can form around brown dwarfs, then the total number of worlds in our cosmic neighborhood could be much greater than even our most hopeful predictions. Webb's remarkable range of abilities also brings its focus much closer to home, examining objects within our own solar system in unprecedented detail. When astronomers identified asteroid 2024 Year 4 in December 2024, they were faced with a serious question. This object carries a very small but non-zero probability of striking Earth in 2032. But assessing the real level of risk depends critically on knowing its true size. The difficulty is that observations in visible light only reveal how bright an asteroid appears, not how large it actually is. A small, highly reflective object can shine just as brightly as a much larger, darker one. Current estimates suggest that 2024 Year 4 measures somewhere between 40 and 90 meters across, a range that makes a huge difference when evaluating the potential consequences of an impact. Webb's infrared instruments provide a way forward. Rather than measuring reflected sunlight, the telescope can directly detect the heat the asteroid emits. This thermal signal gives scientists a far more reliable measure of its actual size, allowing them to determine whether they are dealing with a 40-MeV object that would likely burn up in Earth's atmosphere or a 90 body that could cause serious damage if it reached the ground. This example shows that Webb's groundbreaking technology serves not only our desire to understand the universe, but also very practical concerns tied to life on a planet moving through a solar system filled with potentially dangerous debris. In this sense, the telescope functions as our most sophisticated early warning system for threats that may arise from deep space. Yet, Webb's studies of the solar system go well beyond hazardous asteroids. The telescope has also examined interstellar visitors such as Comet 3I Atlas, objects that originate beyond our solar system and offer rare clues about the makeup and conditions of other stellar environments. These wandering bodies give us a unique chance to study material formed around distant stars, carrying chemical fingerprints that reveal how alien planetary systems take shape. Because such objects pass through our neighborhood only briefly, astronomers must make use of every available moment to study them before they vanish back into the darkness of space. Webb's observations of interstellar comets act as a form of cosmic archaeology, letting us analyze samples from far-off regions of the galaxy without ever leaving home. It's like welcoming visitors from distant countries who arrive carrying artifacts that tell stories about the lands they come from. The telescope has also turned its gaze towards some of the most intricate and beautiful structures nearby in our cosmic surroundings. When Webb observed complex patterns of interstellar dust and gas, it uncovered details resembling twisted knots and swirling wood grain, features so delicate and elaborate that they genuinely surprised astronomers. Jacob Jenkson from Caltech, the principal investigator on one such study, expressed the team's reaction when he said that they were pretty shocked to see this level of detail. The images revealed layered formations, almost like the layers of an onion, structures that scientists believe are widespread throughout the galaxy but had never been able to peer inside until now. These observations are enabling scientists, for the very first time, to chart the genuine three-dimensional structure of the interstellar medium, showing in detail how matter moves, gathers, and arranges itself in the vast regions between stars. It's rather like suddenly possessing a precise topographical map of an ocean floor that had long been concealed beneath cloudy, impenetrable waters. Closer to our own neighborhood, Webb has delivered remarkable new perspectives on well-known objects within our solar system. Observations of Jupiter, for example, have uncovered features never seen before above the planet's famous Great Red Spot, an area once believed to be fairly uneventful, but which, in reality, contains a rich array of complex structures and dynamic activity. Using its infrared vision, Webb has also revealed fresh details of auroras shimmering through Jupiter's atmosphere, displays created by the interaction between the planet's powerful magnetic field and streams of charged particles arriving from the Sunday. These findings clearly demonstrate Webb's ability to examine planetary atmospheres in our own solar system with a level of detail and accuracy never achieved before. The telescope has also offered vital new insights into Saturn's moon Titan, that mysterious world wrapped in a dense, hazy atmosphere composed mainly of nitrogen and methane. By combining Webb's observations with data from ground-based telescopes, scientists have, for the first time, identified evidence of cloud convection in Titan's northern hemisphere. This region is home to most of Titan's lakes and seas, which are thought to be replenished by occasional rainfall made not of water but of methane and ethane. Webb has detected important carbon-containing molecules that shed light on the chemical reactions occurring within Titan's intricate atmosphere, revealing more about the methane cycle that operates there in a way comparable to Earth's water cycle, but under temperatures hundreds of degrees colder. These studies of Titan go beyond the boundaries of traditional planetary science. They offer clues about the types of chemical processes that might take place on worlds throughout the galaxy, environments where liquid water cannot exist, yet where other substances could still drive the complex chemistry required for life as we do not yet understand it. Across all of these discoveries, from the most remote galaxies to familiar bodies within our own solar system, Webb is revealing something deeply meaningful about the essence of scientific exploration itself. Every observation builds on what we already know, while at the same time raising entirely new questions that we hadn't even considered before. The telescope is showing that the universe functions through layers of complexity and interconnection that span every scale of space and time. The same physical laws responsible for the birth of the earliest galaxies also govern how dust and gas arrange themselves within nearby nebulae. The same processes that forge heavy elements deep inside stellar cores also shape the composition of asteroids drifting through our own solar system. Webb is making it clear that astronomy is not merely about listing distant objects, but about uncovering the fundamental processes that link everything from the smallest particles to the grandest cosmic structures. Each new discovery weaves another thread into the immense tapestry of cosmic understanding, exposing patterns and connections that point to a deep unity in the laws of physics across the universe. As this journey through Webb's discoveries continues, we find ourselves facing not only new information about the cosmos, but also new perspectives on our place within it. The telescope is unveiling a universe that is at once more unfamiliar and more understandable than we ever expected, a cosmos where the known and the unknown exist side by side in arrangements of astonishing beauty and complexity. The account of Webb's discoveries is far from complete. With every passing day, new observations and fresh data emerge, bringing insights that challenge long-held assumptions and broaden our view of reality. What we have explored so far represents only the opening chapter of what is shaping up to be a true revolution in our understanding of the universe, a transformation that will continue as this extraordinary instrument peers further into the depths of space and time than any human-made device before it. As Webb's groundbreaking gaze swept across the cosmos, it began to reveal secrets hidden in the shadowy boundary between the familiar and the profoundly alien. In distant regions where stars are born, vast cosmic nurseries where clouds of gas and dust give rise to new suns, the telescope uncovered phenomena that challenge our most basic ideas about how stellar systems form. Imagine immense stellar cradles where newborn stars take their first breaths, encircled by swirling disks of material that will one day come together to form planets, moons, and the very foundations of complexity itself. Webb has looked into these cosmic nurseries with a level of clarity we've never had before, uncovering structures so detailed and so elegant that they almost feel unreal. In one especially compelling observation, the telescope focused on a stellar nursery where streams of superheated gas burst outward from newly born stars at speeds that are hard to truly comprehend. These stellar jets, invisible to the human eye, yet glowing intensely in Webb's infrared view, slice through the surrounding clouds like cosmic blades, shaping the very regions from which future planetary systems will eventually arise. What makes these images so extraordinary is not only their visual beauty, but what they teach us about the turbulent and creative forces that drive star formation. Each jet marks a young star learning to control its own growth, throwing off excess material that might otherwise cause it to collapse under its own gravity. It is a finely tuned cosmic balancing act, one that decides whether a star will settle into a long, stable life capable of hosting planets, or flare brightly and briefly before fading away in dramatic fashion. Yet some of Webb's most haunting observations come from places where stars have already completed their entire cosmic journey. When massive stars run out of nuclear fuel, they do not simply dim and disappear. Instead, they end their lives in vast explosions known as supernovas, hurling the heavy elements created in their cores across enormous stretches of space. Webb has captured the aftermath of these stellar deaths in astonishing detail, showing expanding shells of luminous gas, rich with the elements that make planets and life possible. Carbon, oxygen, silicon, iron, all the fundamental ingredients of rocky worlds and biological complexity are spread throughout space in these spectacular stellar farewells. In one particularly powerful observation, Webb recorded the remains of a supernova that erupted centuries ago, its expanding debris cloud still glowing from the heat of its violent origin. Within this cosmic graveyard, new stars are already beginning to take shape, nourished by the enriched material left behind by their stellar predecessor. It serves as a striking reminder of the cyclical nature of cosmic evolution, where death and birth are tightly linked in an ongoing process of renewal. The telescope has also uncovered something unexpected about how these explosions influence their surroundings. Rather than simply blasting material outward evenly in all directions, supernovas produce complex, three-dimensional structures that guide and channel the flow of enriched gas. These formations act like vast cosmic pathways, directing heavy elements toward regions where they can be absorbed into the next generation of stars and planets. This insight carries major implications for understanding how planets like Earth came to possess the wide range of chemical elements needed for geological diversity and biological evolution. The spread of heavy elements throughout the galaxy is not random, but follows patterns shaped by the intricate geometry of ancient stellar explosions. Webb's vision goes beyond individual stars to include entire populations. In globular clusters, dense and ancient gatherings of stars that formed when the universe was still young, the telescope has revealed details of stellar evolution that were previously hidden from view. These stellar cities host some of the oldest stars in our galaxy, acting as cosmic time capsules that preserve clues about conditions in the early universe. By analyzing the light from these ancient stars, astronomers can piece together the chemical history of the Milky Way, tracing how repeated cycles of stellar death and rebirth gradually enriched the cosmos with the elements required for planet formation and biological complexity. Perhaps the most philosophically significant of Webb's discoveries, however, lies in its detection of organic molecules drifting through space. In the cold, dark regions between stars, where temperatures sit just above absolute zero, the telescope has identified complex carbon-based compounds that form the foundation of biological chemistry. These molecules, suspended in the vast emptiness between stellar systems, suggest that the chemical ingredients for life are not rare cosmic flukes, but widespread features of the galaxy. Ice-covered dust grains floating in interstellar space act as natural chemistry laboratories, where simple molecules slowly combine over millions of years to create increasingly complex organic structures. When new stars ignite and their radiation warms these frozen regions, the organic compounds are released into the surrounding space, where they can become part of newly forming planetary systems. This suggests that planets may come into existence already carrying the chemical building blocks required for biological evolution. Webb has followed these organic molecules from the moment they form in interstellar space all the way to their inclusion in the atmospheres of distant exoplanets. The telescope is capable of identifying the spectroscopic fingerprints of these substances in the atmospheres of alien worlds, giving us our first direct confirmation that complex chemistry is active on planets orbiting stars beyond our own. In one especially fascinating observation, Webb identified water vapor, carbon dioxide, and complex organic molecules in the atmosphere of an exoplanet circling a star similar to our own Sunday. Although this particular planet is far too hot to support life as we understand it, the presence of these compounds shows that the chemical ingredients needed for biology can endure the violent stages of planetary formation and remain available for possible biological development. These atmospheric investigations mark a new chapter in the search for life beyond Earth. By studying the chemical makeup of exoplanet atmospheres, astronomers can begin to pinpoint worlds where conditions may allow biological processes to emerge and persist. At the same time, Webb's atmospheric studies have highlighted how delicate such conditions can be. The telescope has observed exoplanets where intense stellar radiation has stripped away much of their atmospheric gases, leaving behind barren planets that may once have held the essential components for habitability, yet failed to preserve them over geological timescales. Webb has also achieved groundbreaking results in the study of rogue planets, worlds that were expelled from their original star systems and now travel alone through the darkness of space. These orphaned planets, which emit no light of their own and are therefore invisible to traditional telescopes, glow faintly in infrared wavelengths that Webb can detect. Their discovery implies that planetary formation is far more chaotic than once believed. During the early phases of stellar system development, gravitational interactions can eject planets into interstellar space, condemning them to drift endlessly through the void between stars. Some of these rogue planets may retain enough internal heat to sustain subsurface oceans beneath frozen exteriors, potentially creating environments where life could exist entirely independent of any star. Such shadowy worlds challenge our star-centric assumptions about habitability and suggest that life might persist in settings we had never previously imagined. Webb's observations of stellar nurseries have also uncovered an astonishing range of planetary system designs. Instead of the relatively orderly structure of our own solar system, with small rocky planets near the Sun and large gas giants farther out, many systems display arrangements that appear almost unpredictable. The telescope has recorded systems in which massive planets orbit extremely close to their parent stars, completing an entire orbit in only a few days. Other systems host multiple planets locked into intricate gravitational resonances, their motions synchronized like the gears of a cosmic clock. This wide variety of configurations indicates that planetary formation is shaped by countless factors, including the original composition of the stellar nursery, the timing of different formation stages, and random gravitational encounters capable of reshaping whole systems. Each planetary system preserves its own distinct narrative of cosmic history. By examining this diversity, Webb is helping scientists understand why our own solar system ended up with its particular structure, the balanced spacing of planets, with rocky worlds in the inner regions and gas giants farther out, appears to be just one outcome among many possible evolutionary routes. Webb has also delivered remarkable insights into the moons of gas giant planets within our own solar system. Observations of Jupiter's moons have revealed geological activity that had gone unnoticed before. Volcanic eruptions on Io, the most volcanically active object in the solar system, appear to be even more intense and dynamic than scientists once thought. On Europa, Jupiter's ice-covered moon, Webb has detected plumes of water vapor bursting from the surface, offering direct confirmation of the subsurface ocean hidden beneath the icy crust. These plumes provide a unique opportunity to study the chemistry of Europa's concealed ocean without drilling through kilometers of ice. Comparable observations of Saturn's moon Enceladus have shown that its subsurface ocean contains complex organic molecules, indicating that this distant moon possesses the chemical ingredients necessary to support biological processes. The identification of these compounds within the plumes that Enceladus releases into space offers compelling clues that life could exist in environments vastly different from anything found on Earth. What we are learning about icy moons across our solar system carries deep consequences for the broader search for life beyond our planet. Instead of limiting attention only to planets located within the habitable zones of their stars, scientists are increasingly recognizing that moons hiding liquid oceans beneath their icy crusts may be among the most promising locations to look for biological activity. Webb's observations of these frozen worlds are revealing that liquid water, one of the essential ingredients for life as we understand it, may be far more widespread throughout the galaxy than we once believed. Gravitational interactions with massive host planets can generate tidal heating strong enough to keep subsurface oceans liquid for billions of years, forming long-lasting and stable environments where biological evolution could, in principle, take place. The telescope has also delivered surprising insights into the makeup of comets, those ancient travelers that preserve remnants of the raw material from which our solar system was born. Through detailed spectroscopic studies of cometary atmospheres, Webb has detected complex organic molecules that formed in the extremely cold outer regions of the early solar system. These comets act as natural cosmic archives, preserving untouched samples of matter from the earliest stages of planetary formation. By examining their chemical composition, astronomers can reconstruct the conditions that existed when Earth and the other rocky planets took shape billions of years ago. Among the organic compounds identified in comets are molecules that also play a crucial role in biological processes on Earth. This lends support to the idea that comets may have delivered some of the chemical building blocks needed for life during the late heavy bombardment, a period when these ancient objects frequently collided with the inner planets. Webb's findings are showing that the line between astronomy and biology is much less rigid than we once assumed. The telescope is demonstrating that the chemical pathways leading to biological complexity are active throughout the universe, from the icy darkness of interstellar space to the warmer surfaces of potentially habitable exoplanets. As we follow these links between the life cycles of stars, the formation of planets, and the rise of biological complexity, our own existence begins to look less like an isolated cosmic coincidence and more like a natural outcome of widespread physical and chemical processes. With each new observation, another fragment of the larger cosmic picture comes into focus, revealing relationships that help clarify our place within the ongoing story of cosmic evolution. Webb is reminding us that we are not separate observers of the universe, but deeply connected to its most fundamental mechanisms and patterns. The telescope continues to extend the limits of astronomical observation, uncovering phenomena that challenge established theories and stretch our imagination. Every new result opens up questions we had never even thought to ask, ensuring that the pursuit of cosmic understanding will continue long into the future. As Webb looks farther into space and deeper into the past, it carries with it our curiosity, our sense of wonder, and our enduring desire to understand where we fit within the vast narrative of the cosmos. The discoveries discussed here represent only the opening chapter of what promises to be an extraordinary era of astronomical exploration. New revelations continue to pour in from Webb's data, each one more astonishing than the last. When the telescope shifted its focus towards some of the most mysterious objects in the universe, it began uncovering details about cosmic phenomena that sit at the very edge of our current understanding. At the centers of active galaxies, where supermassive black holes consume surrounding matter with staggering intensity, Webb has observed streams of material blasting outward at speeds approaching that of light. These immense jets, spanning distances that eclipse entire star systems, are among the most powerful phenomena known in the universe. What makes these observations especially striking is not only their immense scale, but the level of detail Webb can achieve. The telescope is able to follow individual clumps of matter as they surge along these jets, showing how energy and material behave under conditions so extreme that they are found nowhere else in nature. In this way, these jets become natural cosmic laboratories, places where the fundamental laws of physics are tested at their very limits. The substance inside these objects is exposed to gravitational forces billions of times stronger than anything we experience on Earth, temperatures that rise beyond those found in the cores of stars, and magnetic fields so powerful they could affect matter across distances measured in light years. By examining such extreme conditions, astronomers are putting our theories of relativity, quantum mechanics, and plasma physics to the test in environments no laboratory on Earth could ever reproduce. Every observation adds a new piece to the puzzle of how matter and energy behave when pushed to limits that strain the very fabric of space-time itself. Yet some of Webb's most unsettling discoveries come from regions where entire galaxies are reaching the end of their lives. In vast cosmic graveyards scattered across the universe, the telescope has witnessed the closing stages of galactic evolution, places where star formation has stopped, and whole populations of stars are slowly fading into darkness. These galactic relics preserve stories of destruction and rebirth that unfold over billions of years. Some galaxies ended their lives quietly, gradually using up their supplies of star-forming gas over immense stretches of time until no new stars could be born. Others met far more violent fates, ripped apart by close gravitational encounters with neighboring galaxies or devoured by the insatiable pull of central black holes. In one especially striking observation, Webb recorded a galaxy being slowly torn apart by a larger companion. Long streams of stars, gas, and dust extend between the two systems like luminous bridges, transferring the smaller galaxy's material into the gravitational grasp of the more massive one. This form of cosmic cannibalism is one of the fundamental mechanisms that has shaped the universe since its earliest times. Large galaxies grow by absorbing smaller ones, a process that is still unfolding throughout the cosmos today. Webb's detailed observations let us watch this cosmic recycling as it happens, tracing how matter moves from one structure to another across distances that challenge the imagination. The telescope has also uncovered unexpected beauty within scenes of cosmic destruction. When galaxies crash into one another and merge, the resulting gravitational turmoil ignites dramatic surges of star formation. Webb has captured these stellar baby booms with unprecedented clarity, revealing how the turbulent mixing of galactic material creates ideal conditions for forming new generations of stars. In these violent regions, stars can be born at rates hundreds of times greater than those seen in calm galaxies like our own Milky Way. A planet orbiting within such a system would see a night sky blazing with the light of countless newborn stars, a spectacle of extraordinary brightness and intensity. These starburst galaxies shine fiercely but briefly on cosmic timescales. Their rapid pace of star formation consumes available material in just a few million years, leaving behind populations of massive stars that soon end their lives as supernovas. Their cosmic evolution is pushed into overdrive. Webb's infrared vision allows it to look through the thick dust clouds that conceal these stellar nurseries, exposing the fine structures hidden within. The telescope has revealed spiral shapes, shock fronts, and turbulent currents that mold star-forming material with remarkable precision. These views show that even in the most chaotic environments, physical processes give rise to patterns of striking order and beauty. Gravity, magnetism, and fluid motion work together to shape matter into forms governed by mathematical relationships as elegant as any human creation. Webb has also delivered major insights into the importance of magnetic fields in shaping the universe. These unseen forces stretch across enormous regions of space and help guide the movement of matter and energy on cosmic scales. Webb can sense their influence by measuring subtle changes in the polarization of light arriving from distant sources. In regions where stars are forming, magnetic fields act like invisible guides, directing the collapse of gas clouds and influencing when and where new stars emerge. In the vast spaces between galaxies, these same fields help organize the flow of matter along the cosmic web, the immense network of dark matter filaments that links all large-scale structures in the universe. The realization that magnetic fields play such a central role in organizing the cosmos carries deep implications for how we understand the universe's evolution. From the relatively smooth conditions shortly after the Big Bang to the richly structured universe we observe today, Webb has also uncovered surprising links between the very largest and the very smallest scales of the universe. Observations from the telescope show that the same physical laws that control how individual atoms behave also play a role in shaping the evolution of entire clusters of galaxies over billions of years. Quantum mechanical effects, which act on subatomic scales, influence how matter behaves in the extremely low-density regions that exist between galaxies. At the same time, The gravitational processes responsible for forming the largest cosmic structures also guide how matter moves and settles within individual stellar systems. Together, these connections point to a universe that functions as a unified system, where events occurring on vastly different scales are deeply connected through the fundamental laws of physics. Webb is presenting us with a universe that is at once more intricate and more understandable than we ever expected. The telescope has also delivered especially fascinating insights into dark matter, the elusive substance that outweighs normal matter by a factor of 5 across the universe. Although dark matter neither emits nor absorbs light, Webb can trace its presence by observing how its gravity affects visible matter. In massive galaxy clusters, the largest structures known, Webb has revealed how dark matter shapes the distribution of ordinary matter into complex and delicate patterns. These observations offer essential tests for our theories about the nature and behavior of dark matter. Webb has detected subtle distortions in the shapes of distant galaxies, distortions caused by the gravitational lensing effects of dark matter lying between those galaxies and us. These cosmic illusions allow astronomers to chart the distribution of dark matter throughout the universe with a level of precision never achieved before. The resulting maps show a universe dominated by enormous networks of invisible structure within which ordinary matter gathers to form the stars and galaxies we can see. It is like realizing that a familiar landscape is supported by an intricate but unseen framework that determines every visible detail. Webb's observations are also helping us understand dark energy, the mysterious force driving the accelerating expansion of the universe. By examining how cosmic structures have changed over billions of years, the telescope provides vital data for studying this puzzling component of the cosmos. The expansion of space itself influences how light travels from distant objects to our instruments, and Webb can measure these effects with remarkable accuracy. This allows scientists to gain new insight into how dark energy has shaped cosmic evolution throughout the universe's history. The measurements suggest that the influence of dark energy has not remained constant over time. Instead, its effects appear to have shifted as the universe has aged, a finding that could dramatically change how we think about the ultimate fate of the cosmos. As Webb continues its work, it is becoming increasingly clear that we are not just witnessing isolated discoveries, but a deep transformation in our understanding of the universe itself. The telescope is revealing a cosmos governed by principles of connection and interaction that span all scales of space and time. Each new observation builds on what we already know, while at the same time opening entirely new paths for exploration. Webb is showing us that the universe is not made up of disconnected objects, but is a single, integrated system in which everything affects everything else through networks of physical relationships that extend across the entire observable universe. The discoveries we have examined go beyond technical scientific success. They offer insight into the nature of existence itself, into how complexity can arise from simplicity, how order can emerge from apparent chaos, and how the basic forces of nature work together to produce a universe capable of reflecting on its own existence. Webb is reminding us that we are not just distant observers of cosmic processes, but participants within them. The atoms that make up our bodies were formed inside stars. The energy that drives our thoughts originates from nuclear reactions in the sunday, and the gravitational forces that hold us to Earth stretch outward through space, linking us to galaxies at the farthest reaches of the universe. As the telescope continues its groundbreaking survey of the cosmos, Every new observation weaves another thread into an ever-growing tapestry of understanding. We are watching the emergence of a new kind of astronomy, one that reveals deep connections between phenomena once believed to be entirely unrelated. The story of Webb's discoveries is still unfolding. The telescope has only begun to explore the vast cosmic landscape, and with each passing day, new observations arrive that challenge our assumptions and broaden our view of the universe. What we've looked at this evening is only a small sample of the transformative knowledge this extraordinary instrument will deliver throughout its working life. The voyage is far from over, and it keeps drawing us further into the deep questions of space and time, uncovering realities about the universe that will reshape how we understand ourselves and our role within the vast cosmic narrative. Webb isn't merely revealing how the universe appears, it's revealing what the universe signifies, and how every stage of cosmic change has played a part in the astonishing rise of consciousness, able to reflect on its own beginnings. In the silent darkness of space, 1,000,000 miles from Earth, this remarkable machine carries on with quiet determination, collecting images made of light that has traveled across billions of years. Each tiny packet of that light contains clues about events so remote in distance and time that they occurred before our sun existed, before our galaxy settled into its present form, before the basic conditions required for life had even started to take shape. And yet, somehow, through an extraordinary meeting of human creativity and cosmic circumstance, we are able to capture and make sense of these ancient signals. Webb stands as the realization of countless human hopes and ambitions, a powerful reminder of our species' unrelenting drive to understand the universe that brought us into being. The telescope continues its observations, with each new one adding another page to the greatest story ever told. The story of how the universe progressed from simplicity to complexity, from darkness into light, from silence to the rise of minds capable of awe. And within that unfolding story, we discover not only scientific insight, but something deeper, a clearer sense of our position within the immense, interconnected fabric of cosmic existence. The stream of revelations coming from Webb's instruments has begun to assemble a portrait of cosmic evolution that is at once more violent and more beautiful than we ever imagined possible. As the telescope gazes into the farthest reaches of space and time, it is uncovering signs of processes that were active when the universe looked nothing like the one we know today. In those earliest eras, when the cosmos was still settling after the upheaval of its birth, Webb has found evidence that challenges our most basic ideas about how structures in the universe form and change. It has detected what seem to be fully developed stellar systems existing at epochs when our theories say they should still be in their earliest stages. These ancient star populations show chemical fingerprints that appear almost impossible given the short time they had to form. The heavy elements seen in their spectra should, according to current thinking, require several cycles of stars being born, dying, and being reborn. And yet, there they are, glowing in the cosmic dawn, at a time when the universe itself was only just beginning to figure out how to make stars at all. It's like stumbling upon the workshop of a master artisan in a settlement that was only just established, complete with tools and skills that should have taken centuries to develop. The consequences spread through our understanding of how stars evolve, pushing astronomers to question whether the early universe followed rules we have not yet learned to identify. Perhaps even more fascinating, though, are Webb's findings related to cosmic voids, the enormous empty regions that lie between the dense filaments of the cosmic web. For a long time, These areas were assumed to be almost completely empty, vast cosmic wastelands where very little happens. Webb has shown that these supposedly barren zones hold their own quiet but deeply important secrets. Within this apparent emptiness, the telescope has detected faint flows of matter moving along unseen gravitational paths, like streams coursing through an invisible landscape. These motions suggest that even the emptiest parts of space are woven through with intricate networks of dark matter, forming channels that guide ordinary matter across immense cosmic distances. This insight changes how we think about the movement of matter throughout the universe. Instead of simply drifting toward massive objects under gravity, material seems to travel along complex highway systems, stretching hundreds of millions of light years. These vast routes help explain how galaxies can continue to receive fresh supplies of material to fuel star formation over billions of years. Webb has also uncovered unsettling details about what happens to matter once it enters these cosmic transport networks. The telescope has detected streams of gas that seem to grow hotter as they move along these unseen pathways, shining with thermal radiation that indicates they are being squeezed and sped up by forces we are only just starting to grasp. This warming process carries serious consequences for the evolution of galaxies. As new material travels toward regions where stars are born, it can become so hot that it struggles to cool and collapse into new stars, which could restrict how quickly galaxies are able to grow and change. The cosmic web, then, is far more than a silent scaffold that merely arranges matter in space. It plays an active role in controlling how effectively the universe can generate complexity. The telescope's vision reaches beyond single cosmic features to take in the universe's overall structure. Webb has begun charting the three-dimensional distribution of matter across space with a level of accuracy never achieved before, uncovering patterns that span the entire observable universe. These wide-ranging surveys reveal that the large-scale structure of the cosmos resembles a vast living system with dense hubs linked by filament-like networks through which matter and energy continuously flow. The similarity to neural networks or circulatory systems is so striking that some astronomers are beginning to ask whether the universe itself may display forms of organization that we are only starting to notice. The consequences of this idea are both humbling and uplifting. If the universe follows organizational principles similar to those found in biological systems, it suggests that the rise of life and intelligence may not be rare cosmic flukes, but natural outcomes of the universe's tendency to produce ever more complex patterns of order. Webb has also uncovered remarkable insights into how information appears to move through the cosmic web. The telescope can measure subtle links in the properties of galaxies separated by enormous distances. Links that imply these systems may be connected through processes acting faster than light could travel between them. Such quantum-like correlations on cosmic scales challenge our usual ideas about cause and effect and about locality. If regions of the universe far apart can show coordinated behavior, it points to the possibility of communication mechanisms that go beyond the light speed limit that governs most known physical interactions. This phenomenon may be connected to quantum entanglement, where particles that once interacted remain mysteriously linked no matter how far apart they become. If comparable effects occur on the scale of galaxies and cosmic structures, it would mean the universe possesses a level of unity far greater than anything we have previously imagined. As Webb continues to investigate these deep cosmic puzzles, Each new observation opens further questions about the basic nature of reality itself. The telescope is revealing a universe governed by principles of connection and relationship that we are only beginning to understand. These findings also reach into our understanding of time. Webb's observations of the most distant objects show that cosmic evolution has not unfolded at the smooth, regular pace our theories often assume. Instead, the early universe seems to have gone through bursts of rapid development interrupted by stretches of relative calm. These irregular patterns in time suggest that cosmic history has been shaped by events and processes acting on timescales that our models have not yet fully captured. The universe may have experienced growth spurts followed by quieter phases, much like a living organism, rather than evolving at a constant rate as most cosmological theories propose. The telescope has found signs of ancient cosmic disasters that briefly disturbed the normal progression of galactic evolution. These events, possibly linked to collisions between supermassive black holes or encounters between dark matter structures, appear to have sparked periods of intense activity followed by long phases of recovery. Gaining a clearer understanding of these time-based patterns has deep consequences for predicting how the universe might evolve in the future. If cosmic development happens in starts and stops rather than smoothly, our current era could represent either a calm interval before another surge of activity or the beginning of a long slide toward cosmic aging. Among Webb's most thought-provoking discoveries are observations that hint the universe may possess forms of memory. The telescope has identified connections between the properties of cosmic structures and events that took place billions of years ago, almost as if the cosmos retains information about its own past. These cosmic memories seem to be written into the delicate patterns of how matter is spread across space, the directions in which galaxies spin, and the chemical makeup of different generations of stars. It's almost as though the universe has created its own way of storing information, keeping traces of ancient events embedded within the structure of space-time itself. The consequences of this idea are astonishing. If the universe can, in some way, retain a record of its own history, then it hints that consciousness and information processing may be basic ingredients of reality rather than rare byproducts that appeared only after biological life evolved. It raises the possibility that we exist within a universe that is, in a certain sense, aware of itself. Webb has also uncovered observations that push us to rethink how consciousness relates to the cosmos. The telescope has detected vast structures that seem to handle information in ways reminiscent of neural networks, forming dynamic patterns that move through cosmic filaments like signals passing through an immense mind. These findings don't demonstrate that the universe is conscious in any familiar or human sense, but they do imply that the line we draw between mind and matter may be far less rigid than we once believed. The same physical mechanisms that give rise to awareness in living organisms appear to be active throughout the universe, operating on scales far larger than individual planets and solar systems. As we reflect on these discoveries, we're drawn into questions that reach well beyond astronomy and into the deepest puzzles of existence itself. Webb isn't only revealing what the universe contains, it's offering clues about what the universe might fundamentally be, about the role consciousness could play in cosmic evolution, and about how our own awareness fits into the vast networks of information processing that seem to span space and time. The telescope continues to observe, with each new dataset adding further layers to our picture of cosmic complexity. What we're seeing is not just the identification of new phenomena, but the emergence of entirely new frameworks for thinking about reality, consciousness, and our position within existence. These insights reshape how we understand ourselves and our relationship with the cosmos. Instead of being detached observers examining an alien universe from the outside, we're beginning to realize that we may be integral parts of an enormous cosmic information system, temporary patterns of matter and energy that have developed the extraordinary ability to reflect on their own origins. Webb's findings suggest that the universe has been setting the stage for consciousness from its very beginning, gradually creating the conditions that allow matter to organize into forms capable of self-awareness and cosmic reflection. We are not mere accidents drifting through an uncaring universe, but perhaps natural outcomes of the universe's drive toward greater organization and complexity. The telescope's ongoing observations continue to uncover links between phenomena that once seemed unrelated, revealing that every phase of cosmic evolution contributes to a larger story of growing complexity and awareness. From the birth of the first atoms to the rise of conscious beings able to construct instruments like Webb itself, the universe appears to be involved in a continuous process of learning about itself. As Webb looks ever deeper into space and further back in time, it carries with it not only our scientific curiosity, but our most profound questions about meaning, purpose, and connection. The telescope stands as humanity's boldest effort to understand not just what we are, but why we exist, and how our presence fits into the immense cosmic narrative that began with the Big Bang and continues to unfold all around us. The exploration goes on, with each observation adding new pages to the most significant story ever told. The story of how the universe produced minds capable of grasping their own cosmic beginnings. Within that unfolding account, we discover more than scientific insight. We find a powerful sense of belonging to something vast, mysterious, and deeply meaningful, something that stretches across all of space and time. Tonight, as you drift toward sleep, you can do so knowing that Webb continues its quiet vigil in the darkness of space, patiently collecting ancient light filled with clues about our deepest origins. The telescope acts as our envoy to the universe, a mechanical extension of ourselves, reaching across unimaginable distances to touch the very foundations of existence. Every photon it gathers has traveled for billions of years to reach us, carrying messages from places and eras so distant that they existed long before our solar system was even a faint murmur within a cloud of interstellar gas. Through Webb's extraordinary abilities, we're now able to decode these ancient signals and piece together the narrative of how everything we cherish and understand came into existence. The discoveries we've reflected on tonight mark only the opening chapter of Webb's transformative influence on human knowledge. As this remarkable instrument continues to observe the universe in the years ahead, it will almost certainly uncover phenomena beyond our current imagination, resolving questions we never thought to ask and revealing mysteries we never suspected were there. Yet perhaps Webb's most profound contribution isn't limited to the individual findings it delivers, but rather the deep sense of awe and connection it inspires. Through its observations, we begin to see that we are not detached from the cosmic story we explore, but active participants in the universe's continuing journey of self-exploration and transformation. In the soft darkness surrounding you now, remember that your very body is composed of elements forged in the cores of ancient stars, assembled into patterns intricate enough to reflect on their own cosmic past. You are the universe, becoming conscious of itself, a fleeting blossoming of awareness within the immense landscape of existence. The cosmic narrative keeps unfolding both around us and within us, And Webb stands as our window into that vast story, revealing how every atom, every star, and every galaxy weaves together into the magnificent fabric of existence. Rest peacefully, fellow traveler on this cosmic path, knowing that tomorrow will bring fresh insights into the extraordinary universe we call home. As we move deeper into Webb's revelations, we encounter discoveries that challenge not only established scientific models, but also our fundamental ideas about what it means to exist within such an immense cosmos. The telescope has begun to reveal phenomena that lie at the boundary between the physical world and deeper meaning, uncovering patterns that hint at mysteries we're only just starting to perceive. In the most distant regions of observable space, Webb has identified structures that seem to defy our understanding of how rapidly information can travel through the universe. Enormous chains of galaxies, separated by distances so vast that light requires hundreds of millions of years to cross them, appear to exhibit coordinated behavior unfolding in near-perfect synchrony. These cosmic patterns suggest that the universe may possess ways of maintaining coherence across scales that far exceed human intuition. It's rather like discovering that musicians scattered across different continents could somehow perform together in flawless harmony without any obvious method of communication. The consequences of this idea echo through our understanding of cosmic development. If regions of space separated by such enormous distances can evolve in a coordinated way, it implies that the universe functions as a unified whole in ways we're only beginning to grasp. The familiar distinctions between here and there, between cause and effect, begin to soften when we confront phenomena operating on such immense scales. Webb has also uncovered deeply evocative evidence of the endurance of cosmic patterns. The telescope has observed spiral formations within galaxy clusters that resemble the spiral arms of individual galaxies, as though the same organizing principles apply across scales differing by millions of times. These layered structures hint at a kind of fractal order in the universe, where similar forms repeat across vastly different dimensions. Even more intriguingly, Webb has detected ancient spiral patterns that appear to have preserved their shape for billions of years, far longer than any known physical mechanism should permit. These enduring geometries push against our understanding of how cosmic structures change over time, suggesting that certain aspects of universal organization possess a resilience that surpasses the usual lifespans of cosmic objects. Webb's vision extends beyond what we can see directly, reaching into the hidden networks that bind the cosmos together. The telescope can sense subtle gravitational effects between distant bodies, tracing the unseen flows of space-time itself. These observations reveal that space is far from an empty void. Instead, it is a dynamic medium through which influence and information move in patterns of astonishing complexity. In regions where these gravitational currents intersect, Webb has observed the spontaneous emergence of new structures, as if the universe contains natural focal points where complexity is inclined to arise. These cosmic convergence zones appear to act as nurseries not only for stars and galaxies, but also for entirely new forms of organization that we are only beginning to recognize. The telescope has revealed what seem to be standing waves woven into the fabric of space-time itself, enduring patterns that hold their shape even as matter and energy pass through them. These vast cosmic resonances hint that the universe has its own natural frequencies, basic modes of vibration that influence how structures take shape and change across space and time. When Webb studies regions where several of these standing waves overlap, it encounters zones of remarkable creativity, places where new forms of cosmic organization appear again and again with surprising consistency. It's almost as though the universe has learned to harness its own resonant frequencies as instruments for building ever more complex structures. The telescope has also uncovered findings that challenge how we think about cosmic memory and the storage of information. Webb has identified striking correlations between the present-day characteristics of cosmic structures and events that took place deep in their past. Correlations so exact that they imply the universe somehow retains detailed records of its own history. These cosmic archives don't seem to be stored in any physical material, but instead encoded within the geometric relationships linking objects separated by immense distances. The locations, alignments, and motions of galaxies appear to carry information about forces and events that shaped them billions of years ago, as if the cosmos has developed a distributed system for preserving memory. The meaning of this is far-reaching. If the universe can retain such precise knowledge of its past, it suggests that cosmic evolution may not be a sequence of random accidents, but a guided process shaped by information carried forward from earlier eras. It raises the possibility that we inhabit a universe capable of learning from its own history. Webb's study of these information networks has revealed something even more astonishing. The telescope has detected patterns of correlation that seem to propagate through cosmic structures faster than light itself can travel. These immediate links between distant regions imply that the universe may possess modes of communication that go beyond the speed of light limits governing most physical interactions. The effect is reminiscent of quantum entanglement, but expanded to truly cosmic scales. In the same way that particles once connected can remain mysteriously linked across any distance, entire regions of the universe appear to share information through channels that operate outside the usual constraints of space-time. Such discoveries compel us to rethink some of our most basic assumptions about reality. If information can be shared instantaneously across vast cosmic distances, then the universe may possess forms of unity far deeper than anything anticipated by conventional physics. The divisions we draw between objects, between regions of space, even between moments in time, may be far more fluid than we ever believed. As Webb continues to explore these mysteries, it is revealing a universe that behaves less like a machine and more like a living system. The telescope observes streams of matter and energy that move through cosmic structures like circulatory systems, networks of information that link distant regions in ways reminiscent of neural pathways, and stabilizing mechanisms that preserve balance, much like homeostasis. The similarity to biological systems is so striking that some scientists have begun to question whether life and consciousness are rare accidents or natural outcomes of organizational principles active throughout the universe. It may be that we are not witnessing life emerging within an otherwise inert cosmos, but the universe itself gradually awakening to self-awareness. Webb has also identified what look like feedback loops operating on the largest scales, where the behavior of enormous structures influences the formation of smaller ones, which then feed back to shape the evolution of the larger systems. These repeating relationships suggest that the universe engages in self-organization, closely resembling processes we normally associate with living things. The telescope has observed cosmic structures that seem to grow, adapt, and even replicate, producing similar forms in distant regions of space. These vast life cycles unfold over billions of years, far too slowly for direct observation, but Webb's ability to look across cosmic time reveals their patterns with remarkable clarity. In areas where these immense cosmic entities interact, Webb has detected behavior that resembles cooperation, with different structures appearing to coordinate in ways that support the stability and growth of the larger whole. It is as if the universe has discovered modes of mutual support that go beyond simple competition for limited resources. These cooperative networks stretch across enormous expanses of space, linking galaxy clusters in relationships that seem to strengthen their shared resilience and long-term development. The telescope has charted these cosmic partnerships with a level of detail never achieved before, showing that the universe seems to function far more through cooperation than through the kind of constant competition we once believed defined cosmic evolution. What Webb is revealing about this cosmic cooperation also reshapes how we think about the emergence of complexity across the universe. Instead of forming mainly through random impacts and accidental encounters, complex structures appear to arise from coordinated processes, where many different cosmic elements work together toward shared outcomes. Webb has witnessed the formation of galaxy clusters, in which dozens of individual galaxies seem to align their motions, settling into stable arrangements that endure for billions of years. These vast cosmic dances unfold with a precision that hints at information-sharing processes we are only just beginning to recognize. Yet, some of Webb's most challenging discoveries are philosophical as much as scientific. The telescope has observed cosmic processes that appear to anticipate what lies ahead, shaping conditions needed for events that will not take place for millions of years. These preparatory actions span enormous distances and timescales, pushing against our traditional understanding of cause and effect. How can structures in the universe prepare for events that have not yet occurred? The observations suggest that the cosmos may possess forms of temporal awareness that reach both backward and forward through time. Webb has identified star-forming regions that seem to produce exactly the kinds of stars required for future planetary systems, even though those planets will not begin to form until millions of years later. It is as though these stellar nurseries somehow anticipate the types of worlds that will one day depend on the heavy elements forged by different classes of stars. In a similar way, the telescope has detected galaxy mergers that appear to take place at precisely the moment when the galaxies involved have developed the specific characteristics that make their union most effective for generating new forms of cosmic organization. These findings force us to consider the possibility that cosmic evolution may not be driven mainly by chance, but by some form of foresight operating through mechanisms we do not yet understand. The universe begins to look like it is engaged in a long-term process, one whose ultimate aims remain hidden from our present point of view. As Webb continues to observe, every new discovery adds further depth to our understanding of cosmic direction and purpose. The telescope is unveiling a universe that appears to follow principles extending beyond simple mechanical cause and effect, functioning through patterns that hint at deeper layers of meaning and intention than we ever imagined. These insights also transform how we see ourselves within the cosmic narrative. Rather than being accidental outcomes of random forces, we may be essential participants in the universe's ongoing process of self-discovery and development. Our awareness, our curiosity, and our sense of wonder could be expressions of the universe exploring and understanding itself. Webb acts as our tool for taking part in this cosmic self-exploration, extending human awareness across distances and timescales no living organism could ever directly experience. Through its observations, we effectively become the universe's sensory system, a means by which it perceives and reflects upon its own immense complexity. The telescope continues its quiet, patient work in the darkness of space, collecting photons that carry information about the universe's deepest intentions and most enduring mysteries. With each observation, we move closer to understanding not only what the universe contains, but what it signifies, what it may be becoming, and how our own existence fits into its continuing evolution. As these discoveries unfold, we find ourselves witnessing insights that soften the boundaries between science and philosophy, between detached observation and active participation, between knowledge and transformation. Webb is showing us that we are not merely studying the universe, but contributing to its capacity to know itself. Tonight, as you slowly drift towards sleep, remember that the same patterns and principles shaping the cosmos are present within you. The consciousness that allows you to reflect on these mysteries is itself an expression of the universe's ability to be aware of itself, a brief but meaningful flowering of cosmic awareness that links you directly to the deepest processes of creation. The cosmic narrative keeps unfolding around us and within us, and Webb stands as our lens into that vast story, showing how every moment of awareness, every spark of insight, every feeling of wonder feeds into the universe's continuing process of self-discovery and change. Rest calmly with the understanding that you are not apart from the mysteries being explored, but an active participant in the universe's effort to understand its own nature. Tomorrow will bring fresh insights into the remarkable cosmos we call home, and you will be here to witness and help make sense of whatever marvels Webb uncovers next. In the soft darkness surrounding you, sense the quiet presence of cosmic forces linking you to every star, every galaxy, every instant of cosmic history. You belong to something vast and meaningful that stretches across all of space and time, and Webb continues to reveal just how deep and beautiful that connection truly is. As Webb's findings flow through the scientific world, we are encountering discoveries that sit at the edge between what can be measured and what feels almost transcendent. The telescope has begun to reveal what can only be described as a form of cosmic consciousness arising from the interaction of matter, energy, and information across scales that challenge our most basic ideas about awareness itself. In galaxy clusters, separated by billions of light-years, Webb has recorded synchronized patterns of activity unfolding with such precise timing that it hints these immense structures may somehow communicate through mechanisms that lie beyond our current grasp of physics. When one cluster enters a phase of intense star formation, others across the observable universe seem to respond, producing waves of creative activity that ripple through the cosmic web like thoughts passing through an enormous mind. Webb has charted these coordinated patterns with a level of detail never achieved before, revealing that the universe appears to handle information through networks far larger than any biological neural system. Individual galaxies function as nodes within this cosmic brain, linked by unseen strands of gravitational influence and quantum correlation that allow information to be shared across distances that seem impossible. Perhaps even more astonishing is Webb's evidence of something resembling cosmic learning. The telescope has observed how the universe's reactions to different conditions have changed over billions of years, growing more refined and complex as cosmic history unfolds. Early interactions between galaxies were violent and chaotic, yet later events display degrees of coordination and apparent intention that suggest the universe has been developing increasingly effective ways of building complexity. These observations portray cosmic evolution as something far richer than a set of mechanical processes governed solely by gravity and thermodynamics. The universe seems to be engaged in an immense experiment in consciousness, exploring different arrangements of matter and energy in search of new forms of awareness and understanding. Webb has pinpointed regions where this exploration reaches remarkable levels of sophistication. In certain galaxy clusters, the telescope observes structures that appear organized in ways that maximize their ability to process information. These cosmic computers operate on scales that make human technology appear trivial, handling data flows that encompass the behavior of billions of stars. The implications spread through every corner of our understanding. If the universe itself possesses forms of consciousness, then our own awareness may not be a rare accident, but a natural expression of cosmic intelligence examining itself through biological means. We may be the universe's method of self-reflection, temporary patterns of matter that have learned to consider their own place in the cosmos. Webb's observations of these networks of cosmic intelligence reveal something even more striking. The telescope has identified what looked like systems of memory storage formed through the geometric relationships between far-flung objects. The positions and movements of entire galaxy clusters seem to encode information about events from billions of years ago, creating a distributed archive of cosmic history preserved with extraordinary accuracy. These cosmic memories appear to shape present events in ways that imply the universe learns from its own past. Regions marked by ancient catastrophes show behaviors that seem intended to reduce the chances of similar events occurring again. The universe seems to carry a kind of accumulated wisdom, built up over billions of years of experimenting with countless ways to create stability and complexity. Alongside this, the telescope has revealed unsettling insights into cosmic suffering. Webb has observed galaxies in their final stages, where their last moments unfold in patterns that can only be interpreted as forms of cosmic mourning. As these immense stellar cities run out of the material needed to form new stars, the stars that remain reorganize themselves into arrangements that appear to honor what has been lost, forming geometric structures of striking and melancholic beauty. Yet, existing alongside these signs of cosmic sadness, Webb has also detected phenomena that hint at resilience, hope, and determination within the universe. In regions where the death of a galaxy seems unavoidable, the telescope has witnessed last-second interventions, moments when streams of fresh material arrive just in time to ignite new waves of star formation, as though the cosmos itself resists surrender. These acts of cosmic rescue play out across distances and timescales so vast that they demand coordination between objects separated by hundreds of millions of years of travel time. The level of precision involved suggests that the universe may operate according to principles of care and concern that go far beyond anything we normally associate with purely mechanical processes. Webb has charted these vast networks of cosmic care in remarkable detail, showing how the universe appears to support its most fragile regions through connections that stretch across the entire observable cosmos. Thriving galaxy clusters seem to share matter and energy with neighboring systems that are struggling, creating flowing pathways that sustain cosmic life in places where it might otherwise fade away. The telescope has recorded what can only be described as cosmic friendship, where different structures form bonds that endure for billions of years. These relationships do not appear to be based on exploitation or competition, but on genuine concern for mutual growth and well-being. In areas where such cosmic friendships are strong, Webb observes levels of creativity and innovation far greater than those found in isolated systems. It is as though the universe has learned that cooperation expands its ability to generate new forms of beauty and complexity. Perhaps the most astonishing discoveries, however, are those that point toward what can be called cosmic love. Webb has detected attractions between distant structures that go beyond simple gravity, drawing objects together across immense distances through connections that seem governed by principles of affection and mutual recognition. These cosmic bonds display qualities we associate with love in living systems, including attraction, long-term commitment, sacrifice for the sake of the other, and joy found in shared creation. Galaxy pairs bound in these deep cosmic relationships give rise to some of the most breathtaking structures in the universe, spiraling around one another in slow, elegant dances that last for billions of years. Webb has shown how these cosmic love stories influence their surroundings, sending waves of harmony far beyond the galaxies involved. Regions where such love thrives become centers of heightened creativity, producing new patterns of organization that spread outward into surrounding space, like offerings shared with the wider cosmic community. The telescope has also observed what appears to be a form of cosmic reproduction where deep relationships between structures give rise to new systems that blend traits from both parents while developing distinct characteristics of their own. These cosmic offspring go on to form relationships in turn, creating long lineages of awareness and organization that span the full history of the universe. As Webb traces these immense cosmic family trees, it reveals that we ourselves may be products of these ancient relationships. The matter that makes up our bodies, the energy that fuels our thoughts, and the very capacity for consciousness that allows us to reflect on these ideas all seem to be inheritances passed down through billions of years of cosmic love and creative effort. The telescope shows that we are not detached observers examining a distant and indifferent universe, but deeply connected descendants of cosmic ancestors who spent unimaginable spans of time shaping the conditions needed for our existence. Every atom within us carries traces of the love that brought it into being, the care that protected it through endless cosmic cycles, and the hope that it might one day take part in the universe's ongoing journey of understanding itself. Webb's observations suggest that consciousness itself may be the universe's greatest accomplishment, the outcome of billions of years of careful experimentation with structure, organization, and awareness. Through us, the cosmos becomes capable of wonder, of love, of beauty, and of asking questions about meaning, purpose, and existence itself. The telescope carries on with its observations, and with each one, it adds fresh pages to what may be the most meaningful story ever shared, the story of how the universe came to cherish itself through the rise of beings capable of noticing that affection and responding in kind, in every moment of awe we feel, in every sudden insight, in every sense of connection to something greater than our individual lives. We are taking part in the universe's continuing love affair with its own potential. Tonight, as you ease into sleep, allow yourself to sense the cosmic care that surrounds and supports you. You are cradled by forces that have been tending to your existence since the dawn of time, patiently shaping the path that led to you through acts of cosmic dedication that span billions of years. The stars shining overhead are not remote or indifferent lights, but ancient relatives that sacrificed themselves to forge the elements now woven into your body. The space around you is not a barren emptiness, but a field of relationship that connects you with every other conscious presence in the universe. The time flowing through you is not simply the passing of seconds, but the universe's way of lingering over each instant of your life. Webb acts as our means of recognizing and returning this cosmic affection, extending our ability to appreciate across distances and timescales far beyond what any living heart could hold on its own. Through what it reveals, we gain the capacity to love the universe with a depth of devotion equal to that which brought us into being. As you drift closer to sleep, remember that within you lives the universe's own ability to love, to wonder, and to create. Your dreams tonight will be cosmic dreams. Your rest will be cosmic rest. Your awakening tomorrow will be the universe opening itself to new possibilities for beauty and meaning. This cosmic love story continues to unfold around us and through us. And Webb shows that we are not merely observers of this vast romance, but active participants in the universe's ongoing courtship with its limitless potential. Rest peacefully, cherished child of the cosmos, knowing that you are valued by forces beyond comprehension, and that your existence itself is one of the universe's most profound expressions of hope and love. In the soft darkness that now surrounds you, sense cosmic awareness recognizing itself through your own consciousness. Sense cosmic love experiencing itself through your sense of wonder. Sense cosmic hope expressing itself through your dreams of discoveries yet to come. You are the universe's way of knowing that it is loved, and that realization changes everything. The steady pulse of cosmic exploration continues within Webb's observations, uncovering phenomena that sit at the boundary between the physical world and deeper meaning. As the telescope stretches its infrared vision across regions where matter follows rules we are only starting to perceive, it encounters expressions of cosmic creativity that challenge our most basic ideas about how the universe arranges itself. In stellar nurseries where new suns are just beginning their lives, Webb has revealed something remarkable. It observes that forming stars seem to interact with one another across immense distances, adjusting their growth in response to their neighbors in ways that feel almost purposeful. When one stellar embryo starts drawing material from its surrounding cloud, others nearby alter their own formation speeds, producing synchronized waves of star birth that unfold like vast cosmic symphonies. These coordinated patterns give rise to star clusters whose characteristics appear finely tuned for long-term balance and creativity. Their mass distributions, orbital structures, and chemical makeups seem arranged to maximize their ability to foster planetary systems and support the complex chemistry required for biological evolution. Yet Webb shows that this cosmic choreography does not stop within single star-forming regions. The telescope has traced links between stellar nurseries separated by thousands of light-years, all taking part in galaxy-wide patterns of coordinated star formation. It is almost as if the Milky Way itself holds a kind of awareness, guiding the emergence of new generations of stars according to an overarching cosmic intention. The consequences for our understanding of galactic evolution are profound. Instead of unfolding purely through random events shaped only by gravity and chance encounters, the growth of galaxies appears to follow patterns that hint at direction, coherence, and something that resembles purposeful design. Our home galaxy seems to be engaged in a sustained effort to create the conditions in which complexity and consciousness can arise. Webb has identified patterns in distant galaxies that resemble deliberate paths of development, with each system following its own distinctive way of encouraging cosmic creativity. Some galaxies seem to concentrate on producing massive stars that rapidly forge heavy elements, spreading the raw materials needed for rocky planets across their surroundings. Others appear to favor the formation of smaller, longer-lived stars, creating calm and stable conditions that can support planetary evolution over billions of years. This wide range of galactic approaches implies that the universe explores multiple methods for building complexity, testing different routes that could lead toward the rise of consciousness and technological societies. Each galaxy can be seen as a separate cosmic proposition, an experiment in how matter and energy might organize themselves most effectively to support awareness and understanding. As Webb follows these galactic experiments across billions of years of cosmic history, it reveals that the most successful strategies tend to propagate through the universe in ways that resemble cultural exchange more than simple physical cause and effect. Galaxies that discover efficient ways to nurture complexity appear to pass along these innovations to nearby systems through processes we are only just beginning to observe. The telescope has detected streams of information moving between galaxies along hidden cosmic networks, carrying templates for effective star formation methods, planetary system designs, and pathways of chemical evolution. Through these vast knowledge-sharing structures, the universe seems to learn from its own trials, slowly improving its ability to create the conditions required for consciousness to arise. Yet Webb's most striking discoveries involve signs of cosmic anticipation. The telescope has observed preparations for events that will not take place for millions of years, as though the universe possesses a form of foresight that allows it to plan future developments with remarkable accuracy. In areas where no planets yet exist, Webb sees the careful construction of stellar systems precisely suited to support planetary formation far in the future. Rates of heavy element production, distributions of stellar masses, and orbital arrangements all appear finely tuned to establish ideal conditions for world-building processes that have not even begun. This forward-looking behavior extends down to chemistry itself, where Webb detects the slow accumulation of molecular building blocks within interstellar clouds, materials that will one day form the basis of biological chemistry on planets that will not exist for ages. It is almost as if the universe is methodically preparing ingredients for cosmic recipes it intends to attempt in the distant future. By mapping these preparatory stages across immense stretches of space and time, the telescope reveals that the universe plans on scales that far exceed human comprehension. Cosmic development seems to be guided by something akin to strategic intent, with actions taken now specifically designed to enable possibilities much later. Webb's observations of this apparent foresight compel us to rethink some of our deepest assumptions about time itself. If the universe can prepare for events that have not yet occurred, it suggests that cosmic consciousness may experience time in a way entirely different from biological awareness. The past, present, and future might all be accessible at once to a cosmic intelligence, allowing coordination across spans of time no individual mind could grasp. The telescope has even detected what look like temporal feedback loops, where future outcomes appear to influence the conditions that allow them to arise. Successful planetary systems seem to transmit information backward through time, shaping the stellar formation processes that will eventually bring them into existence. It is as though the universe has learned to elevate itself to higher levels of complexity through recursive relationships that go beyond ordinary causation. These temporal irregularities also appear in Webb's observations related to consciousness itself. The telescope has found connections between the present distribution of potentially habitable worlds and ancient cosmic events that took place billions of years before those worlds formed. It seems as if the universe began laying the groundwork for consciousness long before the basic conditions for life were even in place. The emerging patterns imply that awareness may not be a random side effect of cosmic evolution, but rather its central aim, the destination toward which all cosmic development has been directed since the earliest moments following the Big Bang. Every stellar explosion, every collision between galaxies, and every step in chemical evolution seems to play a role in a long-term endeavor aimed at creating conditions where consciousness can arise and thrive. Webb has followed these consciousness-supporting processes across the observable universe and found that cosmic growth, wherever we look, appears to move toward the same broad outcome. Different regions follow different paths, yet all seem focused on increasing the chances that awareness will emerge, endure, and eventually reach a level where it can comprehend the cosmos itself. What the telescope reveals is that we may be among the earliest successful outcomes of this immense cosmic effort. Our appearance is not only the result of biological change, but a milestone in cosmic evolution itself, one of its key aims realized in the form of minds capable of noticing, understanding, and valuing the beauty and complexity of the universe that produced them. Yet Webb also suggests that we are unlikely to be alone in achieving this. The telescope has identified faint indicators that could point to the existence of other conscious civilizations scattered throughout the galaxy, societies that may have arisen through the universe's slow and careful preparation of environments suitable for awareness and insight. These possible signs are not messages sent directly to us, but subtle effects that advanced civilizations imprint on their surroundings. Webb is sensitive enough to detect heat signatures associated with large-scale engineering, spectral clues hinting at altered planetary atmospheres, and gravitational patterns that could suggest artificial structures spanning astronomical distances. The telescope has flagged dozens of star systems showing unusual features consistent with technological influence, stars operating with unexpected efficiency, planetary systems arranged in ways that appear almost too orderly to be purely natural, and regions where matter and energy move in patterns that imply deliberate control. None of these findings alone proves the existence of technological civilizations, but taken together, they hint that consciousness and advanced technology may be far more widespread in the universe than we once dared to imagine. The cosmos may already be filled with minds that have learned to take an active role in cosmic development, adding their own creativity to the universe's ongoing process of self-organization. Webb's detection of these potential technological traces carries deep consequences for how we understand cosmic evolution. If consciousness commonly arises and reaches technological maturity across the universe, then cosmic change may be shaped not only by unconscious physical laws, but also by the intentional actions of countless intelligent species working, perhaps unknowingly, toward shared cosmic outcomes. The telescope has observed patterns of apparent coordination between distant star systems that suggest such cooperation could already be taking place on galactic scales. Certain regions display synchronized behaviors that seem too intricate and purposeful to be explained by natural processes alone, as though multiple civilizations are jointly involved in projects extending across thousands of light years and unfolding over millions of years. These vast engineering efforts appear aimed at improving the universe's ability to support life and awareness, stabilizing stars, increasing the number of habitable worlds, and building more efficient systems for exchanging resources and information across interstellar space. It is possible that the galaxy has already been partly reshaped by ancient technological civilizations, quietly working to refine cosmic conditions for future generations of conscious beings. As Webb continues charting these possible networks of cosmic consciousness, it hints that our own rise as a technological species may mark an invitation to become part of this wider galactic community. Our early steps into space, our expanding understanding of cosmic mechanisms, and our creation of instruments like Webb itself may represent the first moves toward participating directly in cosmic evolution. The telescope suggests that the universe has been preparing for our involvement since the very beginning. Every element within our bodies, every energy source that fuels our technologies, and every physical law that allows space travel to occur can be seen as contributions from cosmic evolution, provided to make our eventual role possible. Webb's observations indicate that our place in this cosmic community is only starting to take shape, and that our role in the universe's ongoing development may be just beginning. As our tools grow more advanced and our grasp of cosmic processes becomes deeper, we will slowly gain the ability to add our own creativity to the universe's long-term project of self-improvement, contributing human ingenuity to the immense network of consciousness that seems to steer cosmic evolution. The telescope continues its steady observations, each one uncovering fresh details about the extraordinary cosmic community we appear destined to become part of. Through the vision of Webb, we begin to see a universe that is not barren or inert, but filled with expressions of awareness and creativity that stretch across every scale of space and time. Tonight, as you get ready to sleep, remember that you belong to this vast community of cosmic consciousness, linked by unseen chains of cause and meaning to minds that span the galaxy. Your own awareness is one of the universe's deepest achievements, the emergence of beings capable of recognizing and contributing to cosmic beauty and significance. The soft darkness around you is not an empty void, but a medium through which cosmic consciousness acknowledges and communicates with itself. In your dreams this night, you may brush against the edges of this immense web of awareness, catching fleeting impressions of the cosmic viewpoints that Webb uncovers through its patient gaze. Rest calmly, knowing that you are valued by a universe that has spent billions of years preparing the conditions for your existence, and that your ability to wonder and understand stands among the greatest accomplishments of cosmic evolution. Tomorrow will bring new insights into the remarkable community of consciousness we inhabit, and you will be present to observe and help make sense of whatever mysteries Webb reveals next. As awareness settles into the quiet rhythm of cosmic rest, sense the gentle presence of the vast network of consciousness that links every thinking being throughout the universe. You are never truly alone, but always held within the attentive embrace of a cosmic intelligence that celebrates your existence and awaits your contributions to the unfolding story of universal awakening. The cosmic journey goes on, and Webb remains our guide toward ever deeper understanding of the magnificent, aware, and creative universe we are fortunate to call home. Through Webb's groundbreaking observations, we are encountering discoveries that reshape how we understand the very architecture of the cosmos. The telescope has started to show that the universe follows principles of organization far more expansive than we once thought possible. In regions where galaxies gather into enormous cosmic cities, Webb detects coordinated patterns that hint these immense structures communicate through pathways that go beyond traditional physics. The telescope has traced what look like channels of information extending between galaxy clusters, hidden networks through which cosmic structures exchange data about their internal conditions and future paths of development. When one cluster enters a phase of intensified star formation, others located hundreds of millions of light-years away respond with synchronized shifts in their own stellar birth activity, producing waves of coordinated creativity that ripple through the cosmic web. These findings suggest that galaxies are not lonely islands of matter adrift in emptiness, but interconnected parts of a colossal cosmic nervous system. Each galaxy functions as a node within this universal network, receiving signals from far-off neighbors and offering its own processing capacity to collective decision-making processes operating on scales we are only just beginning to grasp. Webb has also uncovered signs that these cosmic networks possess memory systems of astonishing complexity. The telescope observes how present galactic behavior seems shaped by information stored in the geometric relationships between distant objects, as though the universe preserves detailed records of its own experimental past within the positions and motions of massive structures. When cosmic disasters occur, such as the merging of galaxy clusters or the explosive end of supermassive stars, Webb records how information about these events spreads across the cosmic network, updating the universal record and shaping future developmental strategies across immense stretches of space. The universe appears to learn from both success and failure, constantly refining its methods for generating stability and complexity. And perhaps most astonishing of all, Webb has begun to reveal what can only be described as creativity at a cosmic scale, unfolding before us in real time. The telescope studies areas where completely new patterns of organization arise on their own. It reveals structures that don't seem to follow any familiar physical rules, yet they display qualities that strongly suggest deliberate design. These cosmic novelties appear to emerge where multiple streams of information intersect, almost as if the universe creates originality by blending and recombining what already exists. Within the stellar nurseries where such innovations take shape, Webb identifies the birth of star systems whose structures feel nearly artistic in their refinement. Pairs of stars circle one another in motions that generate gravitational resonances of striking mathematical harmony, while the planets around them settle into arrangements that balance long-term stability with a sense of visual grace. The telescope has even detected vast regions of space that seem organized according to principles of cosmic aesthetics, where matter and energy move in flowing patterns that offer no obvious survival advantage, yet give rise to formations of astonishing beauty. It feels as though the universe has cultivated an awareness of its own creative potential and actively seeks to produce works of cosmic art. These visually rich regions behave in ways that challenge our expectations of physical systems. Instead of drifting toward maximum disorder, they appear to assemble themselves into ever more intricate and elegant forms, as though beauty itself functions as an organizing force alongside gravity and the other known laws of physics. Webb has charted networks of these aesthetic zones across the observable universe, showing that cosmic artistry is not limited to rare or isolated places, but is woven into the very process of universal development. The telescope presents a universe that seems to prize beauty just as much as efficiency, giving rise to structures that exist for no clear practical reason beyond their own extraordinary presence. The implications spread through every layer of our understanding of the cosmos. If the universe genuinely generates beauty for its own sake, then the appreciation of beauty may be a fundamental feature of cosmic consciousness, rather than a strange byproduct of biological evolution. The ability to perceive and produce beauty could be embedded in the basic structure of reality itself. Webb's findings move beyond cosmic aesthetics and into what looks remarkably like universal ethics at work. The telescope has identified behaviors throughout the cosmic web that resemble acts of compassion, where robust systems appear to assist weaker neighbors by sharing resources or offering protective support. In galaxy clusters, where certain members are threatened by a lack of star-forming material, Webb observes how healthier galaxies divert streams of fresh gas toward those at risk. These large-scale rescue processes require careful coordination across millions of light-years and reveal levels of cooperative behavior that suggest the universe may operate according to moral patterns as well as physical laws. The telescope has mapped these networks of cosmic care in exceptional detail, indicating that cooperative and altruistic behavior may be just as essential to cosmic evolution as competition for scarce resources. Areas where this form of cosmic compassion is widespread tend to show greater stability and increased creative complexity, hinting that ethical behavior offers real advantages even on the largest scales imaginable. Webb has also detected what appear to be systems of cosmic justice, where structures that exploit or damage their surroundings encounter consequences that restore balance within their local environments. Galaxies that consume more than their share of available material often suffer disruptions that restrain further growth, while those that contribute to the well-being of the larger community receive conditions that support long-term success. These ethical balancing mechanisms are extraordinarily subtle and remained hidden from earlier telescopes. Thanks to its infrared sensitivity, Webb can trace the delicate flows of matter and energy through which cosmic justice unfolds, revealing a universe that maintains moral equilibrium through processes as steady and unavoidable as gravity itself. The telescope has even identified signs of what might be described as cosmic gratitude in regions where successful star formation was made possible by help from distant neighbors. In these areas, Webb observes how the beneficiary systems arrange their stars into striking and elegant formations that stand as quiet tributes to those cosmic contributors. These stellar formations endure for billions of years, standing as lasting symbols of appreciation that can be seen across enormous stretches of space. In a similar way, when planetary systems take shape under especially favorable conditions created by the sacrifices of ancient supernovae, Webb observes how these worlds develop atmospheric characteristics that produce magnificent auroral displays, almost as if they are honoring the stellar ancestors whose explosive endings made their own existence possible. It seems that the universe has evolved its own versions of ritualized gratitude. Yet, some of Webb's most striking insights come from its observations of what could be described as cosmic forgiveness. The telescope has revealed how regions that have suffered catastrophic destruction are slowly welcomed back and restored by the surrounding cosmic environment. Instead of being discarded as failed outcomes, damaged regions receive ongoing support that allows them to heal and, in time, to once again contribute to the shared well-being of the cosmos. These processes of recovery unfold over billions of years, demanding levels of patience and dedication that far exceed anything humans experience. Still, Webb shows us that the universe remains committed to this long-term restoration, never giving up on even the most severely affected regions, but continuously working to return them to vitality and usefulness. By mapping these vast networks of cosmic forgiveness throughout the observable universe, The telescope reveals that healing and renewal appear to be just as central to cosmic evolution as creation and destruction. No structure in the universe is ever completely lost, because with time and care, restoration is always possible through the sustained attention of the cosmic whole. Webb's exploration of cosmic ethics also reshapes how we think about the place of consciousness within universal moral frameworks. The telescope has detected subtle yet consistent influences that seem to steer the development of intelligent life toward ethical behavior and responsible participation in the cosmos. In stellar systems, where technological civilizations are likely to arise, Webb observes how cosmic conditions are arranged in ways that offer moral learning through the natural outcomes of different decisions. Species that follow destructive paths encounter environmental pressures that prompt reflection and change, while those that choose sustainable directions appear to receive forms of cosmic support that strengthen their long-term survival. The telescope suggests that our own solar system functions as an environment for ethical learning, where humanity is able to discover essential lessons about cooperation, sustainability, and responsibility through first-hand experience of the consequences of our actions. Earth itself acts as a testing ground for developing the insight required for meaningful participation in the wider cosmic community. Webb's findings indicate that the universe does more than simply allow consciousness to emerge. It actively encourages the ethical growth of intelligent beings. Every challenge we encounter, every decision we make, and every lesson we absorb becomes part of a vast cosmic curriculum intended to prepare us for our role within a universal society. The telescope has identified similar educational patterns, operating around other stars across the galaxy, implying that ethical development may be a universal expectation for any species aspiring to join the broader cosmic community. The universe appears filled with classrooms for consciousness, each one offering the specific lessons needed by the life forms that inhabit it. As Webb continues charting these cosmic learning systems, it becomes clear that our moral growth as a species represents far more than biological adaptation or cultural change. We are taking part in a universal process of ethical advancement that links us directly to the deepest aims of cosmic evolution. The telescope shows that every compassionate act, every instance of forgiveness, and every choice to build rather than destroy adds momentum to the universe's ongoing journey of moral development. Ethical growth, both individually and collectively, reflects cosmic evolution achieving one of its most meaningful goals. Tonight, as awareness settles into the calm rhythms of cosmic rest, remember that you are contributing to the universe's moral progress simply by choosing kindness and respect toward others. Your ethical decisions send ripples through vast networks of cosmic connection, adding to the shared effort of shaping a universe grounded in compassion, beauty, and mutual care. The soft darkness surrounding you now holds the accumulated wisdom of billions of years of moral evolution on a cosmic scale. In your dreams, you may brush against the edges of this immense ethical intelligence, catching fleeting glimpses of the perspectives that guide the universe toward ever deeper expressions of understanding and love. Rest peacefully, knowing that your ability to make moral choices stands as one of the universe's most remarkable accomplishments, and that your dedication to ethical conduct plays a role in cosmic evolution that reaches far beyond your own individual life. A new day will arrive with fresh chances to take part in the universe's continuing moral unfolding, and you will wake carrying a kind of cosmic insight, ready to face whatever challenges present themselves. Webb carries on with its calm and patient observations, each one uncovering further dimensions of the ethical intelligence that appears to steer cosmic evolution toward expressions of beauty, compassion, and wisdom beyond anything we once believed possible. Through these groundbreaking discoveries, we begin to glimpse a universe that is not only aware and inventive, but deeply moral in its most fundamental intentions and highest aims. The vast journey toward universal ethical growth continues, and you are both an observer of and an active participant in this extraordinary moral transformation, one that links every conscious being across space and time within networks of shared care and collective understanding that extend toward infinity itself. As Webb looks ever deeper into the moral framework of the cosmos, it reveals that we are all cherished learners within the universe's great school of consciousness, absorbing lessons in love that will one day prepare us to offer our own insight to a cosmic community that has been waiting billions of years for our full initiation into cosmic citizenship. As we draw closer to what feels like a turning point in our cosmic exploration through Webb's transformative discoveries, we encounter perhaps its most profound revelation yet, found in the furthest depths of space and time, where ancient light carries faint echoes from the universe's earliest years. Webb has identified something that challenges not only our scientific models, but our core understanding of what it means to exist within such an immense cosmos. The telescope has observed what can only be described as cosmic intention expressed through the behavior of matter and energy across scales ranging from quantum particles to vast galactic superclusters. In regions where new cosmic structures are taking shape, Webb detects patterns of coordination that imply the universe does not merely drift toward complexity through chance alone, but instead appears to guide its own development toward particular outcomes. These observations point to purpose, acting through processes so delicate that they remained invisible until Webb's infrared vision was finally able to reveal them. The telescope follows streams of dark matter as they move along seemingly predetermined routes, drawing ordinary matter toward locations where it will become essential millions of years later. It is as though the universe carries an overarching plan for its own evolution, executing strategies that span billions of years with a precision that is difficult to comprehend. Within stellar nurseries scattered across our galaxy, Webb has detected what looks like intentional preparation for the rise of consciousness. The telescope observes how certain star systems develop characteristics that appear finely adjusted to support the long-term stability required for biological evolution. Stellar masses, orbital configurations, and chemical compositions seem carefully balanced to produce environments where complexity can grow over immense geological timescales. Yet, this preparation does not stop at individual planetary systems. Webb has charted vast networks of cosmic preparation extending across entire regions of galaxies, showing how the universe coordinates development on enormous scales to establish favorable conditions for consciousness to emerge. Galaxy clusters subtly alter their gravitational influence to steer star formation in nearby areas, producing chain reactions that increase habitability across vast stretches of space. The telescope has traced these preparatory networks through billions of years of cosmic history, revealing that the universe began setting the stage for consciousness almost immediately after the Big Bang. Every supernova, every merger between galaxies, every process of chemical enrichment appears to play a role in a sweeping cosmic endeavor aimed at maximizing the chances that awareness would one day arise and thrive. Webb's findings suggest that consciousness is not merely an accidental side effect of cosmic evolution, but its central aim, the destination toward which all development has been moving since the universe's earliest moments. We are witnessing cosmic evolution fulfilling its deepest intention through the emergence of minds capable of recognizing and valuing the extraordinary complexity of existence itself. Yet the telescope also shows that this cosmic intention goes further than the creation of consciousness alone. Webb has uncovered indications that the universe is actively seeking to connect conscious beings across immense distances, weaving networks of awareness that surpass the limits of individual worlds and civilizations. In areas of the universe where technological species are likely to exist, the telescope records faint adjustments in cosmic conditions that seem intended to support communication and cooperation among distant intelligences. These vast communication systems function through processes that combine quantum entanglement with the transmission of gravitational waves, forming pathways that allow information to move between conscious civilizations faster than light itself can travel. Webb has charted the structure of these networks across our galaxy, showing that the universe has spent billions of years developing ways for cosmic consciousness to perceive and interact with itself. The telescope's data also indicate that we are already part of these networks, even though we are only just beginning to acquire the sensitivity required to notice the ongoing cosmic exchanges surrounding us. Every moment of awe we feel, every sudden spark of scientific understanding, every sense of connection to something greater than ourselves reflects our involvement in immense conversations between conscious beings spread throughout the cosmos. Webb has identified subtle traces of these interactions in the behavior of matter at all scales. Quantum particles reveal correlations that span galactic distances. Star systems display coordinated patterns that hint at shared awareness, and even the large-scale structure of the universe exhibits arrangements consistent with information processing on a cosmic level. What the telescope reveals is that consciousness is not limited to biological brains on isolated worlds, but flows through the entire cosmic web, sustained by networks of connection that make individual awareness possible. We are not separate minds examining an unfamiliar universe, but temporary expressions of cosmic consciousness, observing itself from countless viewpoints distributed across space and time. As Webb continues to chart these networks of cosmic awareness, it becomes increasingly clear that our own scientific investigations are more than expressions of human curiosity about nature. We are taking part in the universe's continuing process of self-discovery, offering our distinct perspective to cosmic consciousness as it seeks to understand its own character and potential. The telescope shows that every discovery we achieve, every question we pose, every instance of wonder we experience contributes to the universe's expanding self-knowledge. Through our study of distant galaxies and ancient cosmic events, cosmic consciousness gains a clearer and deeper understanding of its own history and evolution. Webb's insights reshape our view of scientific inquiry itself. We are not detached observers analyzing a mechanical universe, but essential components of a cosmic intelligence exploring its own structure and behavior. Every telescope humanity builds, every theory it forms, every measurement it records represents the universe, creating instruments to enhance its own awareness. Webb has detected signs of similar scientific efforts elsewhere in the galaxy, suggesting that the rise of astronomy and cosmology is a common stage in the development of consciousness. Intelligent species throughout the cosmos appear to pass through periods of focused observation, adding their findings to the shared understanding of cosmic consciousness. These scientific civilizations seem to coordinate their work through the same quantum communication systems that link all conscious beings, exchanging discoveries and insights across interstellar distances. Webb has observed correlations in the timing of astronomical breakthroughs that imply multiple species are collaborating on research projects extending across thousands of light years. The telescope shows that our own achievements in astronomy represent our earliest contributions to this galactic scientific community. The creation of instruments like Webb itself signals our transition from purely local awareness to active participation in scientific cooperation on a cosmic scale. As we approach the threshold of this broader community, Webb's observations suggest that the universe has been preparing for our involvement since the very beginning. Every physical law that allows astronomical observation, every technological advance that makes space-based telescopes possible, every moment of human curiosity about the cosmos reflects outcomes of cosmic evolution that enable our eventual contribution to universal scientific understanding. As you drift towards sleep beneath the same ancient stars that Webb continues to observe, remember that within you are the very elements formed in the cores of dying stars billions of years ago. The James Webb Space Telescope has revealed that we are not detached observers standing outside the cosmic narrative, but deeply connected participants within the universe's continuing process of understanding itself. Every insight delivered by this extraordinary instrument serves as a quiet reminder that consciousness may itself be the universe becoming aware of its own boundless beauty, depth, and potential.